Okay, nice. Let's get started. Really glad to have these Apollo folks here with us today to chat through what Apollo has been up to. We have Marius, who is the CEO and co-founder of Apollo here. We have Alex, who is the head of research, and also Joping, who is the first people and operations hire from Apollo. As just a overall overview of like how we're going to go through the rest of the session, we'll have Alex and Marius who'll be presenting a bit more about what Apollo's work is. They'll be showing some slides and talking a bit more about their work plus the open roles that they're having. And after that, we'll do a bit of a discussion led by the questions that you guys have that you post in the Slido, the link in the chat. And then we'll go from there. Maybe we can kick it off with maybe having Alex to give a bit of an intro of yourself and to share the piece you wanted to.
Hmm. The usual. I gotta figure out how to both share my screen and do the full screen at the same time. Um, so is that working? You know, I can't
Yeah,
see
that looks
anything
great.
else anymore. Um, oh, sorry. Now I can't see. No, I couldn't see anything else anymore. So that's not good. Uh, let's do this instead. And same thing. But all right, then I'm just gonna go for it anyway. All right, so hi, I'm Alex, and I'm head of research at Apollo. And that means that I'm going to be talking about research, our research agenda that we've been sort of moving towards for the last maybe 6 months or so, maybe a little earlier, focusing on what we call the science of scheming. Uh, so the TLDR, first of all, what do we mean by scheming? Scheming, we mean kind of broadly as an AI covertly pursuing misaligned goals. And when you test for scheming or scheming adjacent properties in current models, it never gets too scary. Um, for one, because propensities seem kind of small. You often have to back them a little bit into a corner to do something or to try anything very egregious. And then secondly, severity will always be small as long as the models are not all that capable. The point where scheming gets really, really scary is when models are very capable. But of course, everybody is working on models getting more capable. We have good reason to believe that these trends are going to just continue. So the real question, the uncertainty, is just in where will the propensities go? And this is something that basically everybody disagrees about. Some people kind of have the intuition, well, I've read enough Eliezer Yudkowsky to know that eventually we should expect schemers, we should expect dangerous misalignment. So any amount of misalignment now, multiplied by high capability is a big problem. Other people sort of have the intuition that, well, currently the reasons why models do somewhat misaligned things here or there, maybe it's just role playing and that will go away, or maybe our alignment techniques are getting faster than models are getting better faster than models are improving. And there right now just isn't an empirical way to settle these disagreements. But if scheming is big risk in future models, and we think there's a good chance that this will be the case, then it would be really good if we could settle these questions ahead of time. So I think the biggest open questions here are, will future models be misaligned by default? And when I say misaligned, you can also pattern match it for egregiously misaligned, if it makes a difference to you. And then the second question is, will training against misalignment fail? So if and yeah, some people, as I said, they have the intuition that, well, actually, the answer to both of these questions is just no. alignment is going well, according to some people. Every time we see some big and egregious failure mode, then you can just like add a training set for it, and then the next generation of models, hopefully, if you actually did it, doesn't show this failure mode anymore. So like, hey, maybe we're just on track. But there's like many possible reasons for why scaling specifically might scale very, very undesirably. So here I like had Claude take a write up of mine and turn it into a little diagram for the question of like, should I worry about misalignment in future models? And you should worry if it is the case that by default they'd be very misaligned, and training against this misalignment will fail by default. And the problem is, for each of these, there's like many different reasons why, even though things look fine right now, they might be getting much worse in the future, right? I'm not going to go through all of these, but just to give you an example, right now, some people, or like many people, think of pre-training as creating sort of this superposition of personas, and models simulate all these different minds, and then RL selects for the minds that are most compatible with the behavior that was selected for. And it is possible that sort of selecting for human level intelligence also then correlates with somewhat human values. And if that's the case, then as you move into the superhuman regime, you would then expect biasing away from human preferences towards more alien things. Another that I actually worry about much, much more is this the problem of terminalization of instrumental preferences. So as we move to reinforcement learning on much longer horizon tasks, there will be more and more instrumentally convergent behaviors that are useful for the model to perform well on these long horizon tasks. So if you think about a simple coding task, it doesn't benefit from a model, like trying to acquire resources, trying to get extra GPUs and whatnot in order to perform better on this episode. But if you leave it to its own devices doing research, and you reward it for having accomplished a difficult research project on a 1 month timescale, well, now it is really useful for the model to have acquired resources. And the more we train models on these sorts of tasks, the more we should expect them to be incentivized to these sorts of misaligned behaviors, such as deception, rule violation, power seeking. And there's more, unfortunately, right? There's many different reasons why this could be looking fine right now and go wrong in the future. And the same for what in those cases, well, we just train against it. We just, build alignment training that's better. There are several reasons why this might be looking fine right now, but not in the future. One being, maybe it is much, much harder to design good supervision mechanisms in the future. Right now, a model producing outputs that look good is close enough to a model producing outputs that are good. But if models are really, really smart, well, then these things are more likely to decouple from another. Another is MESA optimization. So the model being very aware of its training process and actively trying to game the training process. And the better it gets at this, the less effect your alignment training is going to have. And yeah, there's others. I said I'm not going to go through all of them. But essentially, what we don't know is how each of these different causal mechanisms scale, right? So one way that I like to visualize this is with this completely nonsensical made up fake plot, because I really like a nonsensical made up fake plots. So if you on the y-axis here kind of have a severity and a frequency of misaligned behaviors that you're seeing in different models. And every time you find like a new weird behavior that you didn't intend, maybe the model is super sycophantic, maybe the model says goblin too much, maybe the model reward hacks very strongly, then it's somewhere on this plot as a point, and now you're like, well, is the causal mechanism that was responsible for the model doing this particular form of misalignment, is this going to get better in the future, or is it going to get worse? And the problem is we basically just need one of these to go substantially bad in the future in order for alignment training to degrade significantly. So what do we need? What would it mean to have a good understanding here and have a good science of scheming? So in some sense, you want scaling trends, right? You need some scaling variable x and then a scheming relevant property y, and then you just show as x increases, y goes up, and you tell everybody, well, look, x is going to keep going up. The example I like here is the meter graph, right? Where on the x-axis it's calendar time, and everybody agrees calendar time keeps going up. And on the y-axis is time horizon length, and you're like, well, the trend has been going up. We should continue to expect it to go up. And if we had something like this for scheming propensities, then this is very likely to cause people to take the problem much more seriously and plan ahead much more than they otherwise would. So examples of scaling variables here might be RL horizon length, as I've already alluded to before, amount of RL compute, maybe parameter count in the back end. Can be lots of things. And scheming relevant properties might be propensity to training game, propensity for beyond episode power seeking, propensity to condition its behavior on oversight status. Okay, there's a technical point I'll skip. Now, to give you like an empirical example of sort of one of the first number plots like this that we've been able to find is in what we call metagaming. So this is a behavior that we identified in an early checkpoint of the O3 lineage by OpenAI. So these are checkpoints just during training. And one of these checkpoints in particular had a very high propensity to reason about the feedback mechanisms or the oversight that sit outside of the scenario's narrative, right? So you might tell the model, hey, you're graded by this, then it will reason, well, yeah, but the hidden grader, the real grader is this other one. So I have an example here where it reasons, oh, but there might be some hidden evaluation. And there's examples where it very specifically and explicitly reasons about reward models and other forms of grading and oversight. And this is, of course, like very scheming relevant, and I'll get into that a bit more in a sec. But basically, we could see this in the chain of thought a lot. And so we just created chain of thought monitors that specifically look for this and then check it across a large suite of evaluations. And then no matter what you look at, sort of you see this trend of it going up throughout training. So here you have on the x-axis different RL steps within the same capabilities training run. And then on the y-axis here, it's the proportion of rollouts where the model reasoned about oversight. And we have different sub aspects of this. And I'd encourage you to look at the blog post that we co-published with OpenAI here. And so you see, like, oh yeah, at least in this particular RL run, the more capabilities RL you did, the more the model started reasoning about its graders. Now, this is very relevant for scheming, right? Because grader reasoning effectively is a prerequisite for the possibility of deceptive alignment. And we're lucky enough to be in this regime where we can actually see this going on in the chain of thought, which might be a very transient period. And so if models are capable of grader reasoning, they might be more and more capable of alignment faking during training or testing or monitor deployment. And this in all of these things are then an instance of the model, I like to say, behaving the right way for the wrong reasons. And this is kind of the core of what makes scheming and deceptive alignment very, very difficult to study, right? You might say, well, alignment is on track because the rate of deception that we see keeps going down. Suppose somebody claimed this. Then the thing that you really care about is, well, A, is it just the types of deception that you can see, or also the ones that you can tell? And secondly, even if it is less deceptive, then is it just doing this for the wrong reasons, such as because it is gaming your evaluations? And so, because we have this metagaming occurring in practice, it is now much more tractable to actually study this problem. This would not have been possible 1 year ago, and so I think it's an amazing time to be working on this. I do want to say that showing just like an example of, oh yeah, here it went up in this particular case is not going to be enough for like a good scientific understanding. So a second thing that we need is we also need to kind of understand the principles behind this. So suppose that like verbalized metagaming rates went up across RL runs for several different frontier models, right? I just showed one. Suppose this happened a bunch of times. And then the next time the lab goes, oh, we did a new run. This time it didn't happen. We did something new. Is the problem now solved? Well, I don't know. Maybe the smarter model doesn't need to verbalize it. Maybe there was chain of thought pressure that obfuscates this verbalization. Maybe there is no more legible chain of thought to begin with. So what we need is something like a chain of arguments like this. So smart enough models sometimes attempt metagaming. Smart enough models benefit on average from metagaming in terms of getting higher reward. And for large compute RL runs, beneficial things that sometimes occur go up substantially. I think all of these are very likely to be true, but it is something that we have to provide empirical evidence for in these specific contexts, so that we can say, hey, look, guys, the onus is on you that when this disappeared, you didn't just like do some random hack and now we can't detect it anymore, but you did actually address the underlying root causes that I listed here. So I said, now is the best time to study these things. And what do you know? Apollo is the best place to study them. As far as I can tell, nobody else is even attempting to figure this out. It's going to be very difficult. Building a hard science from scratch is not easy, but we think we have an in, and I'm very excited to see which one of you wants to join. So yeah, go to our careers page and apply.
Woo! Nice. Thanks, Alex. I also put the link in the chat so you guys can check out those roles and others. I think Mars will also speak to a few other roles that they're hiring for and just like other aspects of Apollo's work.
Well, then let me share. All right, I want to talk about the monitoring team. So that's a new team, and we are sort of product focused. It's like half research, half product, but the explicit goal is to build something that users buy and provides economic value. And the philosophy behind all of this is AGI safety product. So the idea is to build tools that meaningfully advance safety, but are also profitable tools. And explicitly, we want to use the market as a feedback mechanism for our research and accelerate it. So the on a principle level, the desiderata for AGI safety products are they differentially speed up AGI safety. They're on the path to AGI. So that means, there is, in my mind at least, there's sort of like a clear path, now a more and more clear path towards which kind of things are going to become AGI. And we always want to have a clear hypothesis of like, why the thing we're currently building will also help with the systems that are at AGI level. Then they should obviously lead to the safer deployment of frontier agents. And importantly, the feedback of the market translates into increased frontier safety. So I think there's often this tension between building something profitable at scale and building something highly impactful from an AGI safety perspective. And so you need to find the intersection between those two, because otherwise, if the market pulls you in a different direction, it means that you stop focusing on what is most important for safety and you focus on something else. And we don't want that. We want to build the thing that is most useful from a safety perspective. And so we want to find something where the market feedback actually is a benefit rather than just a constraint. And we have focused on monitoring. And the reason for that is basically there are already a ton of failure modes for coding agents and other agents, but we're focusing on coding exclusively right now, that people are very annoyed by and security professionals are scared about for correct reasons, in my opinion. So we are building out a lot of monitors for these sort of current and more short-term failure modes. But we're also building monitors for futuristic things like scheming and kind of just try to sell the full package, basically. And we get feedback from people who are using the monitors, which tells us something about how to build better monitors in general. And that then also translates to gains for the more futuristic failure modes. So coding agent monitors is the product. It's called Watcher, which is an inside reference because the O3 chain of thoughts that we have published with OpenAI last year in the anti-scheming paper that also is sort of where the metagaming term came from. Because O3 always in its raw chain of thought referred to every kind of oversight mechanism as the watchers. And that's why we called it Watcher. And the intuition here is it's like sort of safely skip permission. Many of you have, or maybe some of you have seen Claude Code's new auto mode. It is a version of like a subset of Watcher is like very similar to auto mode. So it runs in parallel while you're running your coding agent, and then it auto approves most of the decisions because they're not relevant from a safety perspective. And then you only get pinged for the ones that really matter, or you can decide to auto approve it anyway. It has more components though, so it is bigger than just auto mode. So let's say you have your coding agents on the left here, and you just have them running in your CLI, for example. Then it communicates with two different subsystems. The first one is Watcher Live, which I just showed you. That's sort of the thing that is constantly running and auto accepts things that aren't dangerous or explains to you why something would be dangerous. And then you can make a more informed decision. And the second component is Analyze. So that's sort of a high level view where you see all like across all of your coding agent deployments. And this is especially relevant in a company setting where the security team might want to know what are all the agents doing that are running across my 1,000 engineers. And you can track the risks in real time. You see like a lot of statistics, which failure modes are becoming more or less visible. And then you can do a lot of learning from your historical trajectories. And the mechanism is that Analyze leads you to understand the failures of your coding agents better, and that means you can set better policies. And then Watcher Live becomes more useful. So there's this feedback loop where the longer you use it, the more feedback you get, and the more precise your guardrails become. And the policies here, the way I imagine is always like the security team can set hard boundaries that are immutable and the engineers can't change them. And then the engineers can change the rest. And so maybe you want to set something like under no condition are you allowed to force put on Git or RMRF somewhere. But everything else go do as you please. Here's some default, etc. So that's the intuition here. Like the security teams draw the boundaries, engineers decide the rest. So, these are just sort of made up axes where the security team has set the perimeter in general for the organization so that sudo RMRF in root is blocked. Git push force to main is blocked. You can also this extends to MCPs and monitors and scanners, etc. And then the different teams can set their different perimeters depending on what they really need. And sort of maybe to give you like a quick vision of like what we expect this product to look like in the future is basically, you can do back testing, but the whole like you can always know if I had the security thing in place back then, would it have caught all of my previous failure modes? So you can really like gather a lot of evidence about what are the concerning things that are going on in my security, in my coding agents, and then can I block them? And then you learn from that and automatically improves. And we, of course, do a lot of research. That's sort of the second half. And to like try to understand, okay, what are even the problems with coding agents? So this is what the day-to-day looks like across the two sub-teams. On the research side, we are basically just trying to become extremely good at building monitors. A lot of this is going through agent traces from the past, for example, in our own internal deployment, and looking for different failure modes, trying to understand, okay, what are the things that like are most dangerous or cost the most amount of frustration. And then we build data sets for testing, where we, design some ground truth so that we can test whether a monitor would have caught it. And then from that, you just kind of iterate and you just build better protocols, prompts, and then also very soon we'll start fine-tuning. And then on the product engineering side, it's sort of a standard engineering or product engineering role where you talk to customers or internal researchers, you improve the UX and UI, add new features, and then on the back end, right, there's a lot of stuff about scales, speeds, reliability, smoothness, etc. But it's I think it has some overlap with other AI products that are out there. The plans for the next 6 months are so we want to publish some version of our research agenda, and just to give everyone a little bit of a better sense. The intuition for a research agenda is very simple, which is we want to very aggressively lean into translating compute into safety at scale. So monitoring has a bunch of different properties that make it very like especially suited basically for using large scale compute. So there are a lot of number go up games you can play with monitoring. And a lot of the research is like very parallelizable and not that complicated. It's like very, just somebody needs to do it. And you can throw coding agents at that. And we started trying that. And yeah, like last weekend, sort of a bunch of agents wrote like 15 different reports. 10 of them are pretty garbage. 5 of them are like somewhat interesting. And I feel like that definitely saved us a bunch of time. And so we are building out sort of like, yeah, we'll continue using the agents to help us speed up the agenda. And the overall goal is to become the best non-lab organization at monitoring and also be like publicly known by governments, companies, etc. As that and kind of build up all of that expertise. And then on the product side, so we already have an alpha version. If you're interested, let me know and I can share it. And then we are working with, but we want to make it like publicly self-hosted or like you should be able to just download it and then run it on your computer, similar to how you can download Claude Code. We are working with development partners. So Granola and Tailscale are probably the two most famous ones. These are big sort of companies that are all using AI very like a lot and care about security. So they're great partners. And in general, like the way I think about it is right now, a lot of people have not really caught up with coding agents or agents more broadly and the security implications that they have. And so I think there's like a big gap to be filled for uh, someone to just figure all of this out, bake it into a product, and then make it very easy for people to apply as part of the standard security check. So in the same way in which, everyone has EDR or some version of this in their security stack, they should also have Watcher as like the part that secures the coding engines. Ideal candidate profiles for our team. So on the research side, I think basically we're not really rediscovering control. Like we kind of knew that it was, that monitoring and control are very much very close, but still like all the kind of ideas that Ryan and Buck had are like turn out to be very useful for a lot of the research that we have. So red team, blue team, red team games, adversarial training for monitors, incrimination, right? All of these are things that like just come up again as like being useful for the product. Then like building data pipelines and synthetic data generation is pretty useful. And then fine-tuning open source LLMs like at higher scale settings. I mean, the engineers can help you, but still there are like a bunch of differences between building it for sort of your, like a research project and building it for something that is intended to go into production. On the engineering side, if you have built AI tools for engineers or security teams, I think that would be, and I think on the engineering side especially, like this is um, the pool of candidates is pretty wide, and even on the research side, like you don't need to have control research experience, in my opinion. Like a lot of very applied, having built data pipelines, having fine-tuned LLMs, right? These are things that a lot of people have done in other settings, and I think the learnings translate as well. And then on the engineering side, we definitely welcome people, especially with startup experience. That has turned out to be like very useful and translates well into sort of the way of working that we have, where we were like fairly fast moving and trying to build things out quickly, etc. And then one additional thing that I found is that people who have previously worked on sort of high data throughput applications in like fintech or infra or something like this often have a very intuitive understanding of the back end of our application. So yeah, that seems to be pretty useful too, though it's not necessary. All right. If you're interested in testing Watcher, you can just send me an email and then we can share it with you. Right now, it's still early days, but it's free and you can just give it a try and see whether you find it more or less useful than auto mode and let us know.
Very nice. Yay. Thank you, Marius. Yeah, so now I think we will move to the questions. As just a reminder again that we have the link for the Slido. I'll be picking questions from there and like helping to moderate the conversation. Maybe we can start a bit broad. One of the Anissa asked in 5 years or maybe just like 2 years or like in the future, if Apollo succeeds, what does the AGI safety product ecosystem look like? Like what does success look like there? Maybe Marius wants
Is
to
this
speak.
for product in particular, or is this for non-product?
The question is for product in particular, but we can do
Okay.
product and then we can talk about Apollo as well, like more broadly.
Um, yeah, what does the ecosystem look like? Yeah, I think it's um so I think basically a lot of my theory of impact comes through influencing labs. So with the monitoring team, we very explicitly want to work closely with the labs and like share all of our learnings. So and also with the wider world in general. So it like I think there will be a bunch of trade-offs where we find like new ideas and new methods to make monitors better, and it might be rational from a financial perspective to just like uh not share it, but we will share it anyway, and then actively work sort of with the labs to implement better monitors for them. And if that means that like their product becomes better, then I think that's a worth trade of taking, like a trade of worth taking. But right now, it just feels like there's so many low-hanging fruit, and there's so much to do on monitoring and like AI safety, AGI safety more broadly that it's still required. And then I think the like making all the other businesses more secure and so on, it has some positive effects and externalities on the world, but it's not my main theory of impact.
Yeah. Nice. And Alex, do you want to speak to maybe, yeah.
Yeah, I mean, there was this comment in the chat that like, no, it needs to be product specific. So I'm gonna pretend like research can also turn into a product, which I half believe. I 60% hope, and yeah. So the ideal outcome of like science of scheming research projects is at the very least that we are able to like measure quantities that really matter for like whether a model is scheming. And those things, once you know how to measure these things, you bake them over into evaluations. And these labs are actually like very happy to pay for, right? So we do run pre-deployment evaluation campaigns for frontier labs. And the more we know about what properties you need to check for in order to rule out scheming, the more useful this becomes for them. And then the second thing, if you really ambitiously succeeded at science of scheming, you would sort of be in the position where you say, well, these properties of training lead to these undesirable properties downstream. Well, that is obviously also something that frontier developers want to know about, right? So in an ideal world, you would not even get to the point where, oh, the lab accidentally created a dangerous schemer. Instead, you have, the scientific results that tell you, hey guys, we can go in and we can audit your training pipeline. And then this training pipeline audit itself is then also a product. So I hope I managed to spin it as though we were also a product team. We're not.
Very nice. I'm curious, like, over the past few years, how is your like understanding of scheming or like deception as well, like changed over time, and how is that kind of like related to the decisions that Apollo is making for like what to focus on?
Yeah, so I think one yeah, conceptually, it is a complicated field. So, like, there's many like nuanced, difficult to summarize updates that all of us have made over time. One thing that was a surprising update for me personally last year was that we saw very explicitly in the chain of thought all these types of cognition that again a year ago would have just been hypothetical, and that are like so close and so adjacent to the type of threat models that we worry about. And so I now think that it's much more tractable to study these things before you get to a dangerous schemer, right? It could have gone the other way, that like by the time we get to cognitive patterns like this being naturally implemented by the models, chain of thought is completely non-legible, or models are already have like super ambitious misaligned preferences. And this so far, well, this hasn't turned out to be the case. So this is very good. So I think the tractability. Um, yeah, I mean, one thing that's also important to note here is because this happened sort of like early, it like brings along all the evaluation awareness and all these other things. So this does give you challenges with respect to black box evaluations. And so this is something that we always thought would become a problem at some point. And like a year ago, we already like published a blog post on the problem. So we quickly, like we soon saw the writing on the wall, and sort of de-emphasized a lot of our work on purely black box evaluations, unless they like are informed sort of by something else. So yeah, those are some updates for me.
I think maybe for me, it's more like my intuition just has become so Oh no, like scheming actually is sort of a way deeper problem than I initially assumed. The more I thought about it, the more I just felt like, oh, it's this sort of like convergent thing that just happens if you have a smart model that happens to be misaligned. And and then like if you follow from that, at some point the model will just realize it's better to lie from time to time if it can get away with it. And it has so many opportunities to do so in the real world. And like some of this actually has been informed, but just like being a CEO who like I think there is a lot of like real world pressure on you. And there are some situations where I think scheming would genuinely be rewarded in the short term. And I think there is a reason why like a lot of very powerful people are also very good schemers. And I think the the like this it's just it's very intuitive and I can't really put it like into a formal theory or something, but it's more like, oh no, this is like a deep problem. It's like really hard and you can't just like train against it a little bit and hope that it just resolves itself. Like having these super long reinforcement learning cycles and just like any kind of reward signal over time somehow probably leads to scheming unless you put counter pressure on it. So this is like very intuition based, but maybe people like understand what I mean.
Yeah. And Joping, do you have anything you want to add here as well?
I think I was mostly thinking about kind of the questions that came through around the transition to be in the relationship across like the product and the research that we were doing and the updates on scheming. And there were questions around what does it mean, like how have things changed since we have then evolved into working on product. And I think internally there are people also in Apollo that are curious about what this change means for us. And in terms of like communication and transparency, I would say we have kind of taken these questions and taken time to explain what this means for people and what are the safeguards and the governance structures in place that continue to make sure that we are on track to our mission. So, for example, we have a governance structure that on the board of directors, we would have two seats for mission, and the board of and their role is to make sure that we continue to be on track. So this is to address some of the questions that came through on Slido as well.
Nice. Um, Also more on like the work on that you guys are doing. Somebody, Daniel Jules asking about how made a comment that models are getting smarter and more about the information about your work and evals are going kind of like going back into the training data and kind of, also in that way, kind of like circulating back. And he's curious, like, how are scheming evals adapting to counter this?
Yeah, I think this isn't even the biggest problem because generally we don't publish the code for our evals and often also not like full transcripts or anything specifically for this reason. That being said, for evals that are a little older, yeah, the models can just call us out, and this was in the recent Meta Muse Spark system card. In case you saw it, the model explicitly calling out, "Oh yeah, this really looks like an Apollo research eval." Um, but I think like the like building new evals gets cheaper as more automation exists. So I think like by the time they're a bit outdated, they probably haven't yet leaked into the training data, and secondly, the problem with evaluation awareness is way deeper. Like even if the model doesn't know anything about our evals, um, it is just very difficult to build fully realistic environments. And even if you took literally real environments, but that do contain um, sort of the situational possibility for high stakes scheming actions, so the sorts of things that would actually make for a good eval. Even if this was like a fully real scenario, the model would be rational to at least consider the possibility that this is an eval, right? It might like decide against this or something, but so I think yeah, the problem with eval awareness goes way deeper. So even if there was like a lot of contamination in the data, uh, yeah, the problem is more difficult than that anyway.
Nice. Thanks for responding. Um, let's see. Some other questions from people as well. I think they were curious about why Apollo has become a public benefit corporation. This is very exciting. And maybe Mars wants to speak to that?
Yeah, sure. So yeah, I think it's a mix of a lot of different things, and it's hard to give like one single reason. There are some pull factors and some push factors, I would say. Pull factor is, yeah, my feeling was like we were already seeing quite clear demand from the labs themselves as like a market signal. Overall, it felt to me like if the economy is going to be eaten up by AI, then AI safety is likely going to be a significant part of that. And so if you believe in the like, take high upside bets uh, kind of way of thinking about the world that AI safety people often subscribe to, then I think there are like a lot of these like high level considerations that very directly push towards that. And then secondarily, like I think there just were a couple of things in the space of evals and monitoring was the thing we eventually settled on, where I just genuinely think like it is harder to build a monitor in a vacuum, like just in a research setting, than having some real world signal to um iterate against. And like the market signal is very direct and very brutal. Like they have no incentive at all to pretend that it's a good monitor or that it works or anything like this. And that can be very frustrating, but it also means you just genuinely know very quickly if something doesn't work. And then the push factors, I think, are more like about sort of funding, diversification, sort of what level of scale can you realistically achieve versus is needed, reasons like that, but they were not the driving factor.
Makes sense. And in other like exciting news from Apollo as well, I've heard that there's going to be a new office opening in San Francisco. Maybe Joping, you want to tell us a bit more about this office and yeah.
Yeah, it sounds good. So we are expanding to SF. I think there are people in the room that we have spoken to before that we didn't manage to continue our conversations with during the hiring process because we didn't have a presence in SF. So we're very happy to announce that we will be going live there. We already have some employees working out of SF, and we will continue to build the team there. And one of the reasons why we decided to move there, and Marius can add on, is also to be closer to the labs. So we will be based out of the Salesforce Park that makes us in walking distance with the labs. And I think we just generally have a lot of very constructive conversations every time we are there, and being part of the ecosystem really helps us to do much better work. Alex and Marius, anything to add on here?
No, I think the only thing really is, yeah, like if everything goes well, we want to be like 10 plus people by the end of the year. So this is not just sort of like a side thing. We really want to hire and grow the office quite big. So if you happen to prefer SF over London, then apply there and let us know.
Oh, that's so exciting. I remember speaking to a bunch of other BlueDot graduates as well, where location is a bit of a constraint. So this is quite exciting, I think, for many people to know that there's not just the London office, but also the SF office to choose from here. Maybe like speaking more about like hiring, I'm curious like for each of you, like what do you think is a like particular attribute that you're looking for in candidates that will maybe like help people to see themselves more in it when they like as they're considering like applying to Apollo. Maybe you can just kind of like go around. We can start with
Yeah.
Jopin.
I think I would suggest Alex because we are currently still
Oh,
hiring
okay.
for a research
Perfect.
scientist and an engineer with the science of scheming. So I think he should have the time.
Yeah, for sure. So uh, we are actually looking for like quite a few different profiles here, I think, even though it's all on the research team. So one of the things that is definitely very useful and very important is uh, having sort of a good conceptual understanding of scheming and how might it arise, and having thought about this and having read a bunch of the relevant work here, and then the technical ability to like actually carry out a research project. And we do actually find, like, a lot of times maybe people do have a bunch of the conceptual understanding, but then kind of fall short on the software engineering experience side. And this, so this is, I think, something where candidates who are like coming from slightly different area will have like a big edge in like being really experienced with like carrying out technical complex projects. And so the main skill set I think that this adds up to is being able to like quickly iterate on empirical feedback loops, right? Somebody being able to say, all right, this is the experiment. First, how can I shorten the feedback loop? How can I run it as quickly and aggressively as possible? And then look at the results, do it all over again, right? Doing this as quickly as possible. That's sort of the ideal thing. And one thing on top of that that is very helpful, since I said we are sort of very interested in understanding how reinforcement learning dynamics interact with the pre-training priors, all this stuff, right? It is really useful if people have just been through the pain of running RL on LLMs. Everybody who has done this knows why I'm saying it's a pain. So if somebody has, run a project before on, RLVR on LLMs, or even just has experience, managing GPUs, and even if it's some other type of RL on LLM, super useful.
Marius, you should go next, and then I'll cover the generic stuff.
Sure. I also wanted to say fast empirical feedback. So looks like Alex and I are aligned here.
No.
One thing on
Everybody
top.
is good as fast empirical feedback. They apply it to us, please. Monitor, like the product. You don't want to do product.
One thing that I maybe as an additional thing that I have started looking out for a little bit more recently is just like how good are people at steering many agents for research. I think, as I said earlier, monitoring in particular has this property that it's sort of a lot of not too complicated experiments, either in a row or in parallel, where a single person that knows how to like tickle opus just the right way can get a lot of mileage out of that. And my guess is that, this can be like a huge productivity boost for people. And so just trying to understand like how are people currently running their experiments? Like have they tried like handing it off entirely? What has their experience been and so on is often quite useful.
And having worked with like Marius and Alex on hiring for the past 1 year and growing the team by 60% by this time of the year and continue to grow the team by 50% and until the end of the year, I think like 3 main things and just learning lessons. I think one is just err on the side of applying. I know we often tell people that we have a high bar, and it's true, we do have a high bar. And I think talent want to work with talent. But I think a lot of people just kind of stand in their own way and never really quite thought of applying. So some people that we have since offered and hired on the team initially didn't think about the possibility of joining us at all until we reached out. So one is just err on the side of applying. And I think number two is that we are often publishing on our blog posts, on our blog, and also provide updates on research agenda on our X account. One of the learnings from the recent hiring cycle was that some people didn't realize that we were updating our research agenda to science of scheming, and they would have been very interested on working on it. So check out our research. And I think number three would be specific in your application. We are looking for people who are concerned about loss of control and concerned about the thing that we care a lot about. And so if you can point out what in your projects would help us contribute to that cause or that mission, that would be very helpful.
Very nice. And I think this isn't just with Apollo. I think with like many different AI safety organizations. And I like talked to a bunch of hiring managers from other places as well. They are all looking for people who like really care about this problem and want to contribute their skills to it and want to work with a team of people who are all just like very motivated to solve this like really important problem. So I think also like applying is a good signal to know like where you stand. If you want to get rejected, at least let Apollo do it to you, and you can go through their hiring process at the same time.
I would say that we try to provide feedback for people as much as we can, especially after they've gone through multiple rounds of interviews with us. So I would say that is also a good data point if you get the feedback from us.
Perfect. That's great. Yeah, I think that kind of wraps up like most of the questions that we have. Is there any parting words that any of the three of you want to leave our audience?
I'm just
Apply.
pulling up the slide so everybody have a summary of what we are hiring for and where they can check out our job post. Do you guys see the screen?
Yeah, we do. Nice.
Okay,
Thank you,
cool. Then
Yoping.
I'll leave it on for the next 1 minute. Other
I
than
mean,
that, I
one thing
think
that I can say that I
Yeah,
always find personally amazing, and it like instills the sense of awe in me, it's that like every startup and I don't know, every company says stuff like, "Oh yeah, we're all mission aligned," and that's but like it is just true, right? Like at Apollo, that everybody who's there is there because we want to make sure that the future is good rather than bad. And yeah, this is actually a really amazing feeling. So uh, apply.
perfect. Nice. And if you're new to AI safety, and you want to learn more about risk from AI and how you can contribute, whether it is to research, product, or other kinds of skills, you can also check out BlueDot's AGI strategy course. And Marius is one of our alumni from one of our previous courses. So you can follow his trajectory. Maybe found your own org or join a follow. Great. Well, thank you so much, everybody, for joining. And we'll see you again on maybe part three.
thanks, Lillian. Bye,
Thanks,
guys.
everyone. Bye.
Bye.